really know if they're harder or not. It's just, you're just going to get a little uncomfortable. That's it. All right, and I don't want you to get frustrated, and don't give up. All right, you'll see right away today with this first proof why it's going to get uncomfortable right away. So maybe I might be exaggerating when I say harder triangle proofs, but you'll see. All right, let's start this off. ER congruent to IT. ET congruent to IR. And I got right angles in the house. TDI is a right angle. And ROE. Make sure we know where that angle is. ROE is a right angle. All right, you guys ready? Look at the proof statement. I'm asking you to prove line segment TD congruent to line segment RO. And we've been here, this unit, right? No way are those line segments going to be congruent unless I do what first?
Prove the triangle.
Thank you. Prove the triangle's congruent. And then do CP/CTC. Are we all in agreement there? I got to prove a set of triangles that contain TD and RO, and then at the end I could say they're congruent by CP/CTC. All right, can we choose a pair? Because there's actually two pair in that diagram that I could choose. I could choose the two on the right and the left, right? TDE and IOR. Or I could do the top and the bottom ones, TDI and EDR. I probably prefer one pair over the other just based on what I was given. What do you guys think? I like the top and the bottom one just because I have what already? A pair of sides and the right angles versus the ones on the left and the right where I only have a pair of sides. Is everyone all right? So that's our goal right now. Let's prove the top and the bottom pair congruent. I should probably say what, though, about my right angles before I get moving? Congruent. Yep, I told you they were right angles, so if we're going to use them, we should probably say they're congruent. TDI, congruent to ROE. All right angles congruent. Well, this isn't too bad, right? I gave you guys a pair of angles and a pair of sides. You only need one more pair or something. Why would these be harder triangle proofs? I don't know. I don't know. We'll see. All right, let's search. Is there anything else in those triangles that we can confidently say are congruent so I can finish this proof? Hi. This is the first time this year that I like hearing silence. Because nobody can find anything, can you? Anybody find any sides or any angles? No, you can't. And that's okay. That's good today. That's what makes these triangle proofs harder. You can't! Guys, there's nothing else you can tell me. There's nothing else. There's no sides or angles in these two triangles that you're going to make congruent at this point in the proof. Does that mean this proof is impossible and we skip it? No, it is still possible. But at this point in the proof, we cannot prove these triangles congruent because I don't have enough information. Good. We all good? So we need to turn our attention now to a new pair of triangles that maybe I do have enough information to prove congruent. Maybe they're not the one I need, but I'll get back to those. We're not leaving them to dead here. All right, we'll get back to those triangles, the top and the bottom. But for now, I don't have enough information. So I'm not going to make my life frustrating and stressful and just keep looking and looking and looking. It's not there. So let's turn our attention. Can anybody find a pair of triangles, any type, anywhere, that are congruent? Because you can. Find a pair of triangles in those that say, oh, wait, whoa, I can prove those congruent. You may not think you need them, but we can. What's up, Reka? Come on. What's up?
Triangle RIO and TED.
We can?
Sure.
How you proving those?
I'm not sure, but you could.
Yeah, I don't know if we could or not. We may run into the same problem with the ones we're on right now. All right, all I have are sides. I could get the right angles next to them, but I'm not going to get a third pair anywhere. And that's the same problem I'm in right now, right? All right, so there's got to be another pair up there I could prove somewhere. What's up, Eric? Take it. You're on fire today. Go ahead.
REI and TIE.
How about the big ones right on top of each other? Everyone see them? TIE and REI. Everyone see those? They're not congruent yet, but I already have two pairs of sides. And what are you guys seeing in those two triangles? What else? I could say EI, right? Congruent to itself. Good. EI congruent to EI, reflexive. I'll pull all this together in a minute. Don't worry. Now, yes, good job. Triangle ETI is congruent to triangle, let's see, ETI. If I go ETI, what do we think here? IRE?
Yeah.
By what method? Side, side, side. Why is this going to help us in the proof? Here's why. And here's the toughest part about today. You just proved these triangles congruent, right? So all their corresponding angles and sides are equal. Well, what problem did we have up here? We were missing something, weren't we? Not anymore, because now they're in these triangles. Does anybody see a pair of angles or a pair of sides that are contained in the side, side, side triangles, and also in the triangles we're trying to prove congruent here? Anybody see a pair of angles or a pair of sides that are contained in my side, side, side triangles, and at the same time are full angles or full sides in the ones I'm trying to prove congruent now? This is the toughest part about today. Can you find those pair they have in common? Find them, find them. Anybody see them here? Grace, you see them?
Yeah.
What are they? First of all, are they angles or sides?
They're angles.
Good. Where are they? What are the angles both pair of triangles have in common?
Angle IER and angle EIT.
Ready guys? Look at the ones I'm marking here. Are those two in the big ones we just proved congruent? And they're in the ones we're trying to prove congruent. So first, how do I know those two angles are congruent? At this point in the proof, why are those two angles congruent, Maisha?
Because it's an isosceles triangle.
It is?
Or because the two sides are.
But the two sides have to be in the same triangle to use that theorem.
Oh.
They can't be in separate ones. Maisha, what did we just do to the big triangles? What did we just do? So that means all their corresponding parts are congruent. So these angles will be congruent by, there you go. Angle T, everyone see here, I can name this angle many different ways. I'll just do TIE. Congruent to angle REI. Everyone see that? That's CPCTC because they're in the big triangles. And isn't that my missing piece now? Isn't that the piece I needed, my third pair of equals to prove these two? Now, are these two triangles congruent? Are they? Are these two triangles we needed at the very beginning of the proof, are they congruent now? Yeah. I got two pairs of angles and a side. We're good. We're good. Triangle TIO, right? TID. Congruent to triangle, if I go TID, REO. REO. What's that method now? Not side, 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 but angle, angle, side. All right, those are the two I needed, so I could finally end this proof and say TD congruent to RO, CPCTC. So this is what we're doing. You're going to pick a pair to try to prove congruent. Most likely you're not going to be able to. You're going to be missing something, like we were missing the angles. So now you have to turn your attention to a new pair of triangles, prove them congruent, and say, what parts do they have in common? Everyone see at least the makeup of today's harder triangle proofs. You're going to be missing a pair. Get over it. Find a new pair of triangles to prove congruent and see if you can find any of their angles or sides to use. Guys, are there any questions here? I know this is not the easiest at the very beginning. Anything here? Going? Okay, let's keep going. I'm not going to send you by yourself yet. One congruent to 2. 3 congruent to 4. Prove QET and QEU are congruent. All right, I have given you a pair of angles, right? 3 and 4. So you guys have one pair of angles. Anything else you can do on your own before we give up? Tim, what else can I do on my own here? Which is QE, QE. Yep. All right, so in those two triangles, I have 3 congruent to 4, which is a pair of angles. And Tim just told me QE, QE. There's a pair of sides. All right, still try to look before we give up. Let's still try to look. Is there anything else you see in those two triangles? You know, don't tell me right angles because they look like them. There's nothing about perpendicular lines here, so give that up. Anything in those two triangles by themselves that you see maybe we could do, and maybe this isn't a tough one at all.
There's vertical angles.
Are they in the two triangles I need?
Oh wait, no.
Right? There are. You're right. There are. But if I take this one and this one, that one's not in the triangle I need, right? So there are verticals, but unfortunately, one of them is not going to be in the triangle I need. Okay. Yep.
Could you say that BQ is a bisector?
EQ of angle TQU I could, but not of side TU I couldn't.
What about BQ?
Say that again.
What about BQ is bisecting TBU?
How do I know that though?
Because 1 and 2 are congruent?
Well, if they're bisecting the angles, yes. But I don't know if it's bisecting TU though. Okay, I 100% agree with you that it is an angle bisector, but I don't know if it's bisecting this segment though. All right. I think we're out of options, aren't we? We're not gonna. We need one more pair of something, and we don't have it. All right, we'll get back to it. Nope, don't get nervous. It's not impossible. We'll get back to it. Now focus. Any other triangles up there maybe that might be congruent? We'll get back to the 2 we need. They'll eventually be congruent, but not right now. Any pairs up here that definitely could be congruent? Let's go, Reika.
QUB.
Redeem yourself.
QUB and QTB.
The big ones on top of each other. Everyone see this? QTB and QUB. I already have 2 pairs of angles. And what do you guys also see I can write down right now? Grace?
You can write the sides across from this angle. Or not the side, the QB.
Yeah.
And QB.
Yep, there's no isosceles triangles in this one. QB congruent to QB. I guess I could put that in statement 2 as well. What's up, Rick?
Could you use third angles here? Too?
To say what?
To say that. Oh, wait, no, because that's just for one.
You could also put that in statement 2 because it's reflexive again. All right, everyone agree that the top and the bottom triangles are congruent now. All right, so here you go. Triangle QTB is congruent to triangle QUB. Ooh, what would be your method then?
Angle, side angle.
Angle, side angle. And like I said in the last proof, here's the toughest part about today. Can you guys find any angles or sides that are contained in the ones we just proved congruent by angle, side angle, that are also sides and angles in the ones we're trying to prove? Can you guys find any sides or angles in common? Because if you do, we're on the right track here. Kevin, you think you got them?
QU equals QT.
QU and QT. Everyone take a look. QU is in the big one we just proved congruent, and in QEU, and QT. Also in the big one we just proved congruent, and QET. Good. So that's what the ones they had in common. So they're congruent. Why are those two congruent? Because they're corresponding sides in these triangles by angle, side, angle. So CPCTC says they're congruent. And then that was my missing piece, right? That gives me another pair of sides. So now I have triangle QET congruent to triangle QEU. And how about I think it's only got to be one method if I have two sides and an angle, right? Side, angle, side. So what are we doing here? We're proving a pair to get another pair congruent. That's what we're doing. Prove a pair to get a pair. All right, you guys ready? All right, if you guys want to hook up with somebody else in the class or try them on your own, it's up to you. All right, it's up to you. You're trying to get triangle DGC congruent to BGA. Maybe I'll do this one here with you too. Two-part proof, it looks like. Let's get the triangles congruent first. If AC and BD bisect each other, you should be able to give me some conclusions now. AC and BD bisect each other. Each other. Anybody got any segments that have to be equal then if they bisect each other? Maddie, go ahead.
AG equals GC.
AG congruent to GC, yep. They bisect each other now. Anything else you want to add to that statement before I write definition of bisector? They bisect each other. AC is not the only thing getting bisected. So is DB. They bisect each other. D. Yep. D. DG congruent to GB. Definition of a bisector. Good job. So look, I gave you have side, side right now. So we're trying to prove those two big ones, DGC and BGA. Anybody see anything else? I don't want to give up until I really, really have to give up. Yeah, I should go ahead. You can.
Okay.
Good job. Where are they?
DGC.
Yeah. Everyone always gets sucked in because they see that line segment EF that throws off their brainwaves. I don't know what the deal is, but yeah, everyone see the verts there? Angle DGC congruent to angle AGB. Yep. You got some verts there. Vertical angles are congruent. Oh, nice. Look at that. And an angle. Those triangles are congruent, aren't they? Nice. Was this a tough? Oh, we haven't finished though. We have not finished yet, kiddos. Angle DGC congruent to angle BGA. Side angle side. Okay. Now, second part, prove GE and GF. Real quickly, can I just say, step 5, GE congruent to GF, CPCTC. Do we understand how CPCTC works is the question. Can I just put that in statement 5 and I'm done? No, why not? GE and GF, are those sides in the triangles we just proved congruent? No, so you can't use CPCTC on it. All right, this is not step 5 CPCTC. I'm done. Everyone understand why first before I move on. They're not sides in the triangles we just proved congruent. All right, well, if you're going to get them congruent, I'd probably recommend proving another pair of triangles that contain GE and GF. That's what you're going to be doing. We still got 10 minutes to end class. All right. Right now, you need GE congruent to GF. And the only way you're going to do that is prove a pair of triangles that contain GE and GF. And see what you can do. All right. Partner up, whatever you guys need to do. You want to try it on your own? I'll leave you 5, 6, 7 minutes to try to figure this out. All right, go ahead. There's a couple ways we could go about it. Prove a pair of triangles congruent that contain GE and GF. And I'll get back to you, talk to people around you guys. Getting tough a little bit? Okay, well, let's talk here. Let's talk. First is making sure you find a pair of triangles that you can actually prove congruent. All right, I don't know how many of you may have started here, trying to prove these two maybe, or the ones on the other two sides here. I don't know if that's a smart idea. Why? Already right away, are those two congruent? No. So why would I pick those? Why not pick instead one of those with maybe this one here? That makes a little more sense because what do you guys already have? You already have that congruent side from the previous part of the proof. So why not start there? Or you could have proved the other pair here. All right, DEG with GFB. I'm just trying to make sense out of this because I don't want to pick a pair I know nothing about. At least if I pick this pair, I'll have a pair of sides already, and you guys already see what else is in that diagram. What else is in this diagram here? Vertical angles. Whether you pick that pair or the pair next to it, you have vertical angles. Angle EGC congruent to angle AGF. Vertical angles are congruent. All right, let's keep going. I got my vertical angles. I need one more pair, right? I got the sides. I got the angles. I need one more pair. Is anybody thinking, why in the world did I make this a two-step proof? Why did I even bother having you guys prove the triangles congruent? To use them. Any angle or side in these triangles we just proved are useful to you. They're fair game. Why are they fair game, Reika? What can you use from those?
GAB and GCE.
How about angle C and angle A? Look at those. Everyone see A. Isn't that an angle in the big one we just proved congruent? And angle C. That's also an angle in the big one. And hey, if you're using the other two I didn't highlight, you could use D and B instead. Angle C congruent to angle A. CPCTC. Guys, here's the big point I'm trying to get across to you before you walk out the door today. If you prove two triangles congruent, use some of their parts now to help you with triangles that you need. All right? If you prove two triangles congruent, use some of their corresponding parts to your benefit. Now are those two triangles I highlighted in green congruent? Yeah, they are. Angle, side, angle. Triangle GAF congruent to, if I go GAF, I got to go GCE. Angle, side, angle. And then, now you can prove my second part of this proof, which was what? Two sides again, GE and GF. CPCTC. That's my big point tonight and why these triangle problems get a little bit harder. Make sure when you prove a pair of triangles congruent, use their parts now to help you out. Use their parts. Because you guys are starting to see, you just can't do it right away. All right, you just can't prove a pair of triangles right away sometimes. Don't give up. Don't you dare give up. Okay, do not give up. There's going to be one of these tougher triangle proofs on Monday's test. Okay, there's going to be one tough triangle proof on Monday's test. All right, and I'm not going to have you guys give up. All right, you can start it up to the bell. Go right ahead. Come in for help, whatever you guys need. I'm here today after school, Friday after school. Get on the review Monday, 5 to 6. Some of you guys haven't been struggling all year, or you haven't struggled your entire math career, maybe until now.